All right, so this one here is probably, definitely, probably, maybe, going to be on the test. And this particular problem is 4.42c. So it's prove via induction that the sum 3 plus 7 plus 11 to 4n minus 1 is equal to 2n n times 2n plus 1. So our base, so the answer that you need is going to have three parts. Put down the basis or the base case, your assumption, and then the proof. Your base case or your basis, basis is what was in the handout and everything else. So write basis is if you just plug in 1. So if you just plug in 1 for n and you verify that they're equal, right? So, or if we just look at the first element of our sum, 3, right? 3 is the same thing that we get if we plug in 1 to our formula, right? So if we plug in 1 for the n's here, we get 3. So that's our basis. They are this side is equal to this side if we plug in 1. Then our assumption is not that for every n, but just that, you know, for some, right? For at least one, or at least when it is true, right? We're just assuming that if we plug in k, it's true. And we can do that because we just proved that it is true when we plug in 1. So our assumption is that we take our left side here and we plug in k for n, and then we plug in k for here, and that is our assumption. Then what we want to prove is that k plus 1 is equal to k plus 1 if we plug in k plus 1 to both sides of our equation. The first step we do is we use our assumption. So when we plug in k plus 1, we'll get the sum, then we'll get the k term, and then our last term will be, in this case, 4k plus 1 minus 1. But then everything before that last term is exactly equal to our assumption. So we can just plug that in here, and we get then our assumption plus our k plus 1 term. And then all we need to do is just the math to solve. We can expand this out and then rewrite it to get down to the right-hand side here. So if you do that, you will see that this here is equal to this here, and that solution for this problem is in the back of the textbook if you want to see what the steps are. But basically what you need to remember is when you're solving a problem like this, plug in 1 for your basis, plug in k for your assumption, then state that you're going to prove it when you plug in k plus 1, and then the first step of your proof is going to be just using your assumption, taking out this part and plugging in this part here, then solve, rewrite until you get to the right-hand side. Yeah, I think everybody's good on this, but it is probably going to be on the test, so I just wanted to go over it real quickly. All right, thanks. Have a good night.